we have a cylinder, okay, and it's called a right circular cylinder. Anybody know why it's called a right circular cylinder? What happens when I draw a line? Makes a right angle, yeah. Makes a right angle from radius to radius. Okay, so let's go ahead and, I'm not going to use Q and N, sorry Quan, but this is a radius, so I'm going to use R. Okay, and what variable do y'all want to use for this? H, hockey. Okay, H for hockey. So what we're going to do is we're going to say, all right, we have a fixed surface area. We can only pay for 16 pi units squared of material. And be it cardboard, if it's a cardboard cylinder, you're at a packing company or whatever, or if there's an aluminum cylinder, if you're in a drink distributor company, whatever. So, and then I want to maximize the volume. Okay, so logically, what is my primary equation here? What am I maximizing? Volume. So my primary equation would be volume. What would V equal? Remember volume of cylinders? Yes. It's just the second dimension. It's volume you get by multiplying area, which is the second dimension, by another dimension to get a third dimension. So here's area. That's the second dimension, area of the base. You take that second dimension area of the base and you multiply it by another dimension to get volume, which is the third dimension. Okay? What dimension am I going to multiply? Well, I already gave it away. I multiply this base, this second dimension, over the height, which is the third dimension, which gives it the mass, the third dimension of volume. But what is the equation of base? What is the area of this base? Pi r squared times height. There you go. There's your primary equation. Problem with this primary equation is, bless you, is obviously how many variables am I dealing with? 2. Well, this one, yeah. Well, really, I'm only concerned with over here. I have 2 variables, and that makes me sad. So I tend to draw frowny faces when I'm sad. And so I need a secondary equation to circumvent that problem. So what my secondary equation is, what is it going to include? It's going to include both the tops, and more specifically, Caleb, you're talking about the working parts. The entire thing is the surface area. All right. So what we need to do is exactly what Caleb was thinking about out loud. Is we need to think about the parts of the surface area. My best example for this is, have y'all ever opened up one of those can of biscuits, that cardboard, and you knock them up against the thing and it goes poof, and the biscuits come out? That's kind of like that. All right, this is kind of like that. So let's say this was a can of biscuits and I cut along the edge. Let's say I use a scissors. Here's my best example of a scissors. Scissors right here. Scissors. I'm cutting the can of biscuits. Open scissors. Open scissors. I don't know. When I cut this open and I take it apart, what parts are left over? Yeah. Of course, the rectangle, after you unfold the biscuits, is still kind of bent like that. All right, your biscuit can is kind of bent. It's a rectangle, though. True that. And you have a circular top and a circular bottom. By the way, this is closed. By closed, I mean there is a top. Okay, and that's very important. That could be important to you making an A on your test or not. You have to know if it's closed or not. All right, so surface area would include the area of the biscuit can after it's open. What would the area of these 2 pieces of the can equal? Pi r squared. And this area would be pi r squared. So we have 2 pi r squared, yes. Oh my gosh. Y'all get that? No? Well, I know this piece is the height. Alright? But the problem is, if I call this piece the length, then I'm in trouble. Because I've instituted another variable. Bad. Okay? So what we do is we look back over here and we ask ourselves, what is the length? Yeah. The length is how far around that piece wrapped. See? It's still kind of bent from where it wrapped. So the length is actually the circumference, which is 2 pi r. So instead of area equals length times width, it's going to be area equals, height. Well, I don't want to write it like that. What should I write?
2 pi r.
2 pi r times h. Yeah. Very good. And there's only one of those, so plus 2 pi r times h. Okay. And there we go. Wheels turning. What do I do next? I want to solve, but I also need to plug in what? Yes, the given surface area. 16 pi equals 2 pi r squared plus 2 pi r h. Now,
What is the u squared? Is that just units?
Is that just a unit you put it on the end?
yeah, no, I don't put the units because this is not physics. This is calculus. I give you easy units, and you don't have to think too much about it. Okay, so don't bother with the squared and stuff. Okay, so what should I solve for? Should I be hard on myself and try to solve for r like a madman, or should I just solve for h? Right, so solve for h. This is easy. What's my first step?
Subtract 2 pi r.
Sure. Some of you crazy kids are like, factor out of 2 pi r. Okay, no. 16 pi minus 2 pi r squared. What's the last step? Yeah. So, how would I go about simplifying this?
Just factor out a pi, and then
Yeah.
just take pi out.
Yeah.
Forever.
Yeah. Yeah. What do y'all want to do? Factor out a pi or factor out 2 pi?
2 pi.
2 pi. So, what's left?
8 minus r squared plus
Yes. Yes. I like to make noises when I simplify. Alright, so h is equal to 8 minus r squared over r. So, we do this, and we draw a star, because we like stars. And here's the other star. So make the stars come together. What do I get? Go ahead and plug it in. Plug that mammoth thingamajigger in. You get pi r squared times that whole heap of mess. What do y'all want to do that? We can distribute. What am I gonna distribute it to?
The top.
The top. Just one piece of the top or the whole top?
Whole top.
Ah, yes, the imaginary parentheses here. Okay, so the whole thing? You want to distribute all of it? Okay. Anybody else got another idea? Come on, I know you want to say it. What else could I have done there? Ooh, no. Not that. I'm not that crazy. But there's a little crazy stuff I wanted to maybe do here. You could maybe do this.
Wait, what did you plug in? You plugged H back into the original secondary equation, right?
Not the secondary equation, the primary equation,
Ah.
the red one.
Oh. Yep, this is it.
Okay. Hey, what could I do with these two R's?
Cancel.
Cancel. So there's one way to skin a cat. But since we're already doing it this way, let's just continue. What do y'all want to do?
Factor out an R,
Okay, factor in an R.
or an R squared.
Yeah. R's cancel. Alright, y'all know the drill. Take the derivative, set it equal to 0, solve.
Can we do decimals?
Yeah, you can, but try not to.
Only after the square root.
Well, just leave it in the square root. Sorry, I know you're waiting on me. Alright, what's the approximation? What's the decimal?
I don't know.
No say. Okay. Alright, what do I do?
I'll plug that into
Yeah.
the.
Yeah, plug it into, where is it at? H? Right here? Yeah, do it to it. Do it up. If you're a beast.
Can you scroll back down?
Yeah, sure. If you're a beast, you don't use a calculator right there. Just saying.
So, what happened to the prime?
They canceled.
Oh yeah, that's right. Damn.
Right here.
When we're at the top of the screen right now. We factored out an R.
Yeah.
We factored R out of both sections.
No, I took the derivative. DDR. Alright.
One above it.
Yes, I did. I factored out an R. And then I marked them out because they canceled. Alright, so while y'all are working out for H, I'm going to show you what real Americans do when they have a irrational number. Do not try this at home. Well, actually, I would like you to try this at home, but don't let it frustrate you too much. Crazy, crazy, crazy. How would I simplify that? How would I simplify that? Come on, somebody step up. Well, you don't need to do anything. You can just plug it in your calculator if you want, but you can actually do that. What next?
Oh my.
Yep. Whoop, I didn't flip. What next?
Flag cross.
Yeah? What next?
Plug it in the calculator.
Yeah. Plug in the calculator.
No,
We're
come
done
on,
here.
one more step, please.
No.
Multiply by 16.
No, you can't do
That
that.
doesn't work, just
Yeah. What happened to this guy? Come on. This guy right here.
8.
Yeah.
2 square root.
Yeah.
2.
2 squared root of 2, so it's 16 over 3 times 2 squared root of 2. Square root of 3 on top. What else?
And you multiply 8 over 3.
Yeah. 8 over 3 over square root of 3 times square root of 3 over square root of 2. That's how Chuck Norris does it right there. Okay?
That's why you have Chuck Norris condensed.
Chuck Norris in a calculator.
Yeah, he does it every calculator.
Alright, no, you don't have to do this on the AP exam, but I need to expose you to it. I'm like inoculating you here. But I know you already used your calculator. So what is H in decimal form?
3.266.
3.266?
Yeah.
Okay. I'll go with that. And so what's your volume?
27.361.
What?
Eh?
The V, I got 7.4467. What?
And 7 point, all that times pi should be, yeah?
Oh, I put the pi in there.
That's okay. So it should be pi times, what is it, 3.266 squared? 266 squared. Wait, no, that's the radius. Dang it. Pi times 1.633 squared.
Times 3.266.
Alright, yeah. Okay, and that should give you 27.361. I think. This is all guesstimation. It's about right.
Did I mess up this bill?
What'd you get, Kwon?
I got 7.4467 as well.
That's right.
What?
You didn't multiply times pi.
Did it?
You did?
You might have put it in again.
Did you square the 1.633?
Yeah, I got 8 over 3 as that instead.
Mm-hmm.
8 over 3 is R.
R is not 8 over 3.
It is not.
This is square root of 8 over 3.
Okay, that's where I'm from.
Yeah.
Okay, got you.
Alright. How are we doing? Now I know this is a lot, but let's backtrack. Let's reflect. All it is a primary equation of volume. Alright, secondary equation of surface area, and a whole lot of math and calculus in between. Okay? What's the probability of making an error?
Very high.
Pretty high. So you just gotta focus. And look, I grade. Y'all know how I grade. If you make an error in a previous step, I don't care. There's no error carryover. I assume that I marked you off for that error, and then I assume everything else is right, based on what the problem looks like right there. So when you started off without your 2, who started off without the 2 in the problem? Yeah, that's -1 basically. Okay. So, all right, moving on. We don't have much time, but I kind of want to get started on a new problem. So let's just get started on it. This one's not too bad, but I tell you what. We'll go for 4 more minutes and then I'll assign homework. Okay. And basically, the learning. I know that we don't get a lot of time to work on stuff in here, guys. But I promise you, I'm showing you this stuff as fast as I can. I mean, would you like me to go faster?
No.
Okay.
Yes. Shut up. I'm kidding.
So here's And quick story, take 30 seconds. Somebody just came in for tutoring for calculus in college. This stuff they did in a day. And he had a test with all different types of optimization problems on it. Okay, and they did it in a day. So imagine it. I've got like 6, 7 more things to show you. Imagine if we all did that in a day. Okay, so I'm sorry that you don't get time to work on your homework in class, but do you see my logic for working till the bell? Hopefully.
How long is the class?
I mean, it's probably a 2-hour class, but at the same time, that's just 2 days for y'all, and this is probably going to take us 3.5 days. So yeah.
See how.
Should we go over homework and then take pictures of changes?
All right. So here's the deal.
I can do it.
You start out with a flat sheet of cardboard, sheet of aluminum, sheet of metal, whatever it is that you're working with. Okay? And then you start cutting. You cut a square of X size out of each piece. Okay? Out of each corner, my bad. Okay? So that piece is gone. And then you fold on these red dashed lines. Well, one day you might be working as a marketing director, and you have to make an ad, and it involves optimizing this sort of material. I don't know.
Nah, son, I'm avoiding all the math I can get.
All right. So,
Coach,
yes.
that's how I draft my shoe boxes. I like cut out the corners and then I fold them into
A viable
Yeah.
application.
Viable application. And you know who came up with those dimensions? A calculus teacher or person. All right. All right. Let's see. So we started with a complete solid material, and then we cut these pieces out. And we need to go ahead and start with dimensions. Give me a simple number. Somewhere. No,
3.
that's actually not simple.
250.
It needs to be large.
250.
12. Jeez Louise. Something with a lot of multiples, people. All right. And let's say this is 24. So, you know, you think that the 1, 2, or 3 is easy. No. You need something with a lot of multiples to make it easy. So when you fold this, you're going to end up with some sort of shoebox or whatever you're making, or packaging box, or
Viable NHS hours.
yes, viable NHS. I don't know what that means. Alright.
And just like using viable.
So you kind of treat it as a prism, but all these are basically X's, okay? They're basically X's. So now that's what you have. And what I want to do is maximize the volume. Of this prism by finding X. Okay? Alright, where's that? Oh, right there, right there, right there, right there, right there. No. So you want to maximize the volume, and I'll tell you what, we'll get started on this tomorrow. It's about time. I need to go ahead and give you homework. So, obviously for homework, we only got to go over one problem today, unfortunately. But,
We only have one problem.
well, I'll leave that up to you. I got 2 problems for you. Okay. This is the one that we did not do so well. This is the one we did kind of poorly on last night because we had a lot of people kind of just messing up with the basic logic of it, and just like simple small errors, you know.
Yeah.
So we can't. I wouldn't say that's poorly. Actually, I just wrote it. Let me erase that out. That's not poor. It just happens. But if you want to do number 1, okay, do number 1. But we've already done one like it, okay. but I would just go back and do it. Number 1 and 2 seemed easy for y'all, but this is like number 3 that we kind of struggled with, and this is the one I want you to do tonight. All right? It's got no top though. What would that mean if it has no top?
It means it's just S squared.
Yeah, just.
Yeah. Yeah. Well, not S squared. It's got a circular base.
Oh, well, it's not too
It's not.
high.
It's not too powerful.
Yeah, it's just pi r squared. Yeah. All right. So that's it. Okay. I guess y'all can kind of take a deep breath because bell's gonna ring in about 30 seconds. Okay.
Don't even tell them about it, just bring it into school.
I can find some features.
Oh, geez. Thank you.
I'll leave it for you. This thing on iPhone. Have you seen like the shuffling now? The shuffling. It's random ones that have been uploaded. So like it's all the old ones.
So random features?
Random features.
Oh, that's
So you can
perfect.
spend like hours on it.
I spent 3 hours on iFunny yesterday. iFunny is amazing. I spent my time doing bibliography. Yeah, I should.
We got the book.
Before that was like in the Arab world.
Yeah, I just put it in
Tell
like
me short a little
license
bit.
for me or whatever. And I just have to teach it, so I don't.
When I was reading it,
Really?
it was
Okay.
in it, so I got it on my iPad and I looked at episodes of that one.
Like in
I'm like, oh, that's watch the entire episode.
Yeah, I just go on like all day about like
Oh, I was just like, he did not like what I said. He was like,
I read.
he was like, he was like, I'm gonna lay down. There's only 20 like, and he said he calculated the sauce. Yeah. Like, I would have been.
Have a wonderful day in the neighborhood.
that mine slide
It's a beautiful day in the neighborhood.
Let's look at what today's gonna be. We have to turn in 25 sources.
But then I just reworded the
Really?
question.
Yeah. As long as it looks specific.
I might be in a 10-page paper I have to do this weekend. Oh. Have a great day. Woo! That's good. Oh, no! It's a beautiful day in the neighborhood. Won't you be mine? Jessica, we practiced a whole bunch yesterday. We've been doing the same.
I'm really sick, and my mom had to take me to the hospital yesterday because I get really bad headaches, and I took pills and they don't go away. And they did exams on me, and they said I was supposed to get them back like next week.
I'm sorry. The heat should be on. Check it. I'm sorry.
I didn't do number 2.
Number 2, what?
Were they supposed to turn out similar?
The homework?
Yeah.
I gotta remember which problems I gave you. Right now, I've got so many homework
We got
problems written down.
X4, it's the X4.
Oh, the X to the fourth power? Oh, yeah.
I don't remember how to do that one.
Oh, we just do it the same way.
Oh.
Use rational root theorem.
Oh. Really?
Yeah.
I was like, what did we learn to do it for?
Yeah.
Yeah, like X to the fourth power or something.
Okay. I got it from, I guess Office Depot or whatever. -3. All right. Okay, guys, turn your homework in, please. Yeah, me too. Alright, wrap it right here. When I get out of that, didn't see the pass out thing up here. I need a couple people passing out. Summer things. I got you, coach. Yes, ma'am. And of course, you have fire. We gotta get practice. All right, guys. There's a warm up. It's about to be on the board. You need to start it on your notes. Somebody can pass these out for me.
Wait, we start.
Yeah. She's giving Gerardo. Yeah. Just needs a little trim. Hey.
I don't have that.
Yes, I see it all over your face. All right, guys, warm up will be on the board shortly.
Did I put it in right?
Well, I thought it was the fourth power.
Mine
Let me see your.
That's how I wrote it.
You already turned it in? All right, guys, we're having a real bad time. Let's put it back in the tray. Having a real bad time getting started here. Your warm-up is the first problem that you see. It says warm-up on it. Okay, we're not going to go off of the flip chart today. Just going to go off of my notes. So you need to be doing the warm-up. Okay, put it back in the tray, please. And if anybody's absent, is anybody absent? Everybody here? Oh, Juan's not here. Could you please put copies of each in Juan's box, Maria? Could you please put copies of each in Juan's box? Thank you.
Where's one? This one, like one.
And Jessica. Juan and Jessica's box. So please copy of each. Okay, guys, you should be finding the intersections of those two functions. It's different than what we did on your homework, okay? Set them equal to each other. Add the x over.
Oh.
And you got a GCF. Yes. Well, first you gotta set them equal to each other. So you got this y over here. Get rid of that y. You don't need that y in there.
I'll just keep it right
Okay.
there.
No. Oh yeah. Bring that down. Add that over. Negative 2x plus
Hey guys, I forgot our GCF.
Yes. Equals 0. Equals 0. Now do the GCF, guys. GCF and dots this one. Alright. Let's take a look at it. One more on. Yes. Yep. Wait. No, you need to factor out a common factor of x. Oh, I see what you did. Let me show you real quick. All right, guys. So let's talk about this one right here. Okay. You got x cubed minus 2x equals negative x. You add x to both sides. Guys, show your steps, please. Some of y'all are just killing yourselves not showing your steps. X cubed minus x. All right? They have an x in common. So I'm going to take an x out. Wish I could find my better pen. There it is. So watch. Take an x out. I don't understand why we're talking. That's part of the problem. All right? And then you could factor that even more. That's dots. What does it factor into? What does it factor into? X plus 1, X minus 1. We should know that. And then, so what answer does this factor give me? X equals what? 0. What answer does this factor give me? X equals -1, and this answer gives me X equals 1. Okay, before we start today, I'm going to go ahead and tell you that the quiz grades were not that great at all. In fact, only probably half folks passed, which is not good. I expect more out of y'all, but I expect more out of myself. So I'm going to give you all a chance of redemption. I'm going to give you a couple more problems to do tonight. Use open note. If you turn it in tomorrow, great. What's tomorrow? Friday? It needs to be done by tomorrow. Okay? So at the end of class, we're going to do that. But we're going to get through this too. And I don't know, I may even give you over the weekend. Depends on how y'all do today. Alright, so a geometric sequence. Alright, well, we found the x's. My bad. We also need to find the y's. Which one is going to be easier to plug these into? This function or this function?
The first one.
Yeah, the first one. So, plug in 0, what do I get? 0. Plug in -1, what do I get? Positive 1. Plug in positive 1, I get -1. So, my points, my intersection points are 0, 0. What else? -1, 1. And 1, -1. Okay, those are my intersection points. Alright? These are my final answers. Put a star on it. Something. Smiley face. Alright, cool. So, let's start with our notes. We're going over geometric sequences first. Alright? So, a geometric sequence is a pattern where each number is multiplied by some number to reach the next number in the sequence. So it's a pattern of multiplication. Alright? Next, the number used to multiply by to get the next number is called the common ratio. Sorry. Oh, I need to zoom out a little bit. Alright, common ratio. The number used to multiply to get to the next number is called the common ratio. The variable used for the common ratio is r. Okay? Cool? Alright, example 1. I want you to write down 2, 4, 8, 16, 32. Dot, 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 dot. Okay?
Does this still have to do with graphing or we on something different?
This is not anything to do with graphing at all. Okay? Okay. So, go ahead, if you want to differentiate a little bit here, go ahead and write down what the pattern is. Times 2. If the pattern is times 2, R is 2. Okay? Yeah, you should remember this from 9th grade. Alright, so next example. Write the first 4 terms of the geometric sequence where a sub 1 equals 2 and r equals 3. Okay? So, what does a sub 1 equal? Or, sorry, 2. What does it mean, though? First term. So, 2 is the first term. Kind of like 2 is the first term right here.
So is R3 the same multiplied by 3?
Yeah, R3. Alright, so let's say, let me put my blanks. My blanks for my sequence. R is just whatever you do in between. It says times 3. Okay? So y'all should be able to figure that out like lickety split, dude. Y'all got them? What day is?
18, 30, and 54, and 160.
What, 54?
Yes, sir.
And
162.
162. Okay, good. All right. Now, the nth term, meaning any term you want. So this is for any term you want. Any term you want, you use a formula. A sub n is equal to a sub 1 times r the n minus 1. My notes are wrong, but I fixed them. It's okay. We know, what does a sub 1 stand for? First term. What does r stand for? What does it say? Ratio. Common ratio, and this is an exponent. Now, the one thing you're gonna mess up on is your exponent needs, well, actually, I tell you what, don't worry about it, because you're always gonna minus 1. You'll be fine. That's actually in parentheses, but you don't have to put the parentheses, because you're always gonna minus 1 first anyway. Alright, so write the formula and find the 10th term of the geometric sequence 2, 4, 8, 16. Dot, dot, dot. So, the formula would start off with a sub n equals this number. What is it? 2, because it's the first term. Alright? What is this number? Ratio. Now, here's where you will mess up. Oh, we multiply them by 3? 2 times 2 times 2 times 2. Okay, so r is 2. Parentheses, people. You must put your common ratio in parentheses. If you don't, it will forever make your life miserable. Because anytime that r is negative, you're going to end up with half your answers will be wrong. Okay? Alright, so to the n minus 1. Always. Yeah. Now, if I want to find the 10th term, all I do is plug in 10 for n. Oh, I didn't plug in 10. That's a 10. Sorry. I know I'm being sloppy. Sorry. That's a 10. Yes, it needs to be in parentheses. But you don't need to write your time sign. So you could just do 2 parentheses, 2, 10 minus 1. Before you put this in your calculator, go ahead and minus 1. A sub 10 is equal to 2 times 2 to the 9th power. So what does that give me? I can't write a sub 10, apparently. Can't write it. Huh? No, the exponent you could just write, just do caret 9. In fact, this is how exactly to look in your calculator. 2 parentheses 2 caret 9. That's exactly how it'll look in your calculator. 1024. Alright, so this is really awesome because you can calculate exponentially large quantities with a simple formula. Really awesome. Really awesome. Okay. So, y'all ready for the next one? Okay. Write the formula and find the 16th term of 1800, 900, 450, 225, ... Let's talk about this first. What's going to happen if you keep dividing at this rate? It's going to get really small. It'll probably eventually be a decimal, just to let you know. But what are we multiplying by? Nope. Okay. Well, let me address Caitlin, your response. If I was minusing by 900, then that would be 0. It is dividing by 2, but you can't use division. You have to say times something. So yeah, times 0.5 is the same thing as dividing by 2, right? So just do times 0.5. Or if you're a fraction man, times a half. Or woman. Okay, so our formula, a sub n is equal to, what do I put first? 1800. Why? First term. What do I put in my parentheses? 0.5 caret to the n minus 1. Okay, now let's do, this is my formula, now let's plug in 15, a sub 15, no, 16, a sub 16, my brain's going mush, times 0.5 to the, what should I write up here, 16 minus 1 or just 15? Just 15, yeah. Alright, so go ahead and calculate it the same way you calculated the last one. Anybody got it?
0.054.
Dot, dot, dot. Okay? So all that, dot, dot, dot. Okay? How y'all feel about this so far? Easy peasy lemon squeezy? Okay, just make sure you never put dividing by 2 or dividing by 3. It's always whatever the decimal is. See, and here's a trick. If you're dividing by 2, watch. If you're dividing by 2 and you don't know what that decimal is, just do 1 divided by 2 equals 0.5. If you're dividing by 3 and you know that and you don't know what that is, what should I use? 1 divided by 3. And you'll get 0.33 repeating, but you can round that, you can approximate that to 0.33. Okay? My bad. So anytime you're dividing and you don't know what your decimal is, just do 1 divided by that number. Anytime you're dividing, you're going to end up with a decimal. Just think about, how do you multiply and make something smaller? Multiply by a decimal. Or 0, yeah. Multiply by decimal. So anytime something's getting smaller, it's going to be a decimal. Okay, so a geometric series now. Now let's talk series on the back. A geometric series is a geometric sequence whose terms are added. Added. I put the emphasis on the wrong syllable. Okay, so, whoops. All right, so the formula for the sum of n terms in a geometric sequence. Oh my gosh, it's ugly. So it's S of n is equal to a sub 1, 1 minus r to the n power over 1 minus r, and that's it. But r cannot equal 1. Okay, difficult looking formula, simple concept. All you're doing is plugging in 3 things. All you're doing is plugging in 3 things. Alright, so on the next example, I'm going to show you it. Let's write it down. The next example is find the sum of the first 6 terms of this geometric series. If I say 1, 2, 4, what if I don't give you the next 3? Because you need 6 of them. Can you figure out the next 3?
Yeah.
What are they? 8, 16, 32. Because you're timesing by 2, so use the pattern if you have to. Alright? Now, all we do now is add those. And we're done.
Wait, so we add all of this?
You just add all of them, yeah. Sure enough. 63, 64, 55. All right. 63 for real? All right. Okay, so that'll give you 3. That'll give you 12. That'll give you 48. Oh, you're right. Oh, my bad. 63. I thought it was 64. Okay. That's it. Now, why do we need a complicated formula? Because the formula allows us to do like really large numbers. Okay? So let's try the formula off on the side. And these are two different ways of adding. Pay no attention to that. Does that confuse anybody? No? Okay. All right, so let's do this complicated formula for this problem right here. We're finding S of 6. Wait, let's write the formula first. My bad. S of n. Okay? The summation. What does sum mean? Add, right? Right. So what's the first term in this series? 1. So a sub 1 is 1. And in my big old fraction, I do 1 minus what? Oh, my bad.
1 minus 2.
Why is it 2, Orion?
Because
That's the ratio. So my ratio is times 2, times 2, times 2, times 2. So it's 1 minus 2 to the nth power over what? 1 minus 2. Okay? So if I want to find the sixth term, it's S of 6 equals 1 times 1 minus 2 to the sixth power over 1 minus 2. What's 1 minus 2? Negative 1. So S of 6 is equal to 1 times, what's 2 to the sixth power? 64. What 1 minus 64 over negative 1. Work out the top all the way. Yeah, S of 6 equals 1 times negative 63 over negative 1. Bam. What is negative 63 divided by negative 1? 63. What's 63 times 1? 63. Booyah. Yeah. So it's just like a simple formula that you just plug into that makes it easier to add. Okay? Who thinks up of this stuff? People with lots of time on their hands. Actually, this is the type of stuff that's in second year calculus, and so yeah, this is a second year calculus, convergence and divergences of sequences and series, and this stuff is used in huge technological applications. I mean, it's used all over the place. Yes. Can you put it all in the calculator? If you were to put it in the calculator, I would only put this in the calculator. Then you divide by whatever's down there. Then you multiply. Yeah, those are the steps. Look, top, divide, times. Boom. That's what I would put in the calculator. All right, let's move on to the next example. Next example, find S of 5 for 3, 9, 27. How many terms do I need? How many do I have? So I need 2 more. What are they?
81 and 243.
Very good. Now, that's a 9. Now, y'all want to do the formula or add it up? Okay. Cool. Just add it up. Let's see what we get. $363 verified? All right, 363. Hey. First you give them the googly eyes, now you're all over them? Jeez Louise. Alright. Okay, next example. Find the sum of the geometric series. Oh my goodness. Now we have some more notation to learn. All this is notation. Do not be afraid. I said don't be afraid.
I
Don't
always
be.
wonder what that little E backwards looking thing on a calculator was for.
That's all the calculator? I have this.
You don't need the calculator for that.
What is that? I'm just looking. That's not on my calculator.
All right. Okay, guys, this is the last thing we're doing, so focus, and then you get to start on your homework. Okay. Find the sum of the geometric series. What do you think I do?
Oh, this got imaginary numbers and stuff in it too.
No.
Oh, I'm just saying you got the law.
So, yeah, I know, but look at this. Look, what do you think I do now?
You plug stuff in.
Yes. So, I need you, don't put it here, put it up here. 3 times 3, plug in what?
1 minus 1.
1 minus 1. Well, what should I really put? Come on. 0. Because 1 minus 1 is 0. Well, what's 3 to the 0 power? No. No. 1. 3 to the 0 power is 1. What's 3 times 1? 3. Bam. On to the next one. Let me show you. What? Okay, hold on. What do you think I'm going to plug in? What do you think I'm going to plug in next?
2, 5.
No, I'm going to go 1, 2, 3, 4, 5. I'm going to go 1, I'm going to plug in 1, then I'm going to plug in 2, then I'm going to plug in 3, then I'm going to plug in 4, and I'm working my way up to what? 5. So, on the next one I plug in 2, the next one I plug in 3, the next one I plug in 4, okay? What? I haven't plugged in 2 yet. I haven't plugged in 3 yet. I plugged in 1. Now, look, I've got to plug in 2. Plug in 2 to I. So that's 3 parentheses 3 to what power? 1. Because 2 minus 1 is 1. So what's 3 to the first power? 3. So 3 times 3 is? 9. Now I'll move on to the next one. 3. What do I plug in next?
3 to the second power.
I plug in 3. So what's 3 minus 1? 2. So 3 times 3 to the second power.
That's 20, you get 27.
Yeah. You get basically, you get 3 times, sorry, my handwriting is fading. 3 times 9? What's that? 27.
Then you get 81.
Yeah, and now basically you've got a pattern, so what's my pattern, y'all?
3
Times 3 times 3. Now do you even need the formula? No. So what's the next number? Am I done? Do I have to do any more? How many do I need? I need 5, so I need one more. 243. Damn. Huh? The original one? Oh, that's given. All this is given to you. The last one is 243, yeah.
Coach,
Yeah.
how much harder would it be?
Okay.
Would it be like, let's go from 3, 9 to like jump to like 81?
No. Well, I guess no.
Or will it go like 3, 9, and then it get like.
It'll multiply 7 times the same thing every time.
That's what I'm saying. So it don't, that's about it.
That's about it, except for this. Look, what if this was, same problem, Ryan, same problem, but instead of 1 to 5, it was 1 to 10.
Yeah, I was about to ask you that.
It would still equal 3, so you start off with the same thing, right? 3, 9, 27, ... But let's say it was so many numbers, 1 to 10, that you got tired of plugging them in. Now you got your formula. Okay? You got the formula. You could use this formula. All right? What's the first term?
3.
So y'all remember your a sub, we just went over it. 1 minus r squared, r to the n, over 1 minus r. So I tell you what, somebody add all those up. No. Let's try this. 1 to 10. No, y'all, let's do this one. 1 to 5. Let's do the same problem. Let's say, Orion, you didn't want to add those 5 up. Okay? So 27, 81, 243. Let's say you didn't want to add them up. You didn't want to. Use this formula. 3. Why is it 3? Because it's the first term. Yes. It's the first term. What is R, y'all? R is 3. Why? So you do 1 minus 3 to what power? Fifth, because we're finding how many? We're adding 5 things. So to the 5th power over 1 minus 3. You just plug all that in. Okay? So I tell you what. Somebody's already added that up, I'm sure. What's the answer? Who's already added all this up?
We did it. It was like 6.
360.
Yeah.
363? Somebody plug all this in your, plug this top part. Just plug this top part in your calculator. One minus 3 caret 5. Negative 242. Is that what you got?
Yeah.
Okay. Now divide that by, what does this become?
2.
Negative 2. So divide negative 242 by negative 2.
121.
121. Okay. So now we got 3 times 121. What do we get?
363.
See how it gives you the answer? Now, would you rather add them all up like this over here, or do it this way? Add them all up. But what if that was a 12?
Then I do it that way.
Then you probably do it this way. Okay. All right. So we got a couple more examples that we'll take real quick, and then I'm gonna let y'all just do your homework. All right. This next one. Here we go. I'll try to write around that 363. Summation. We're gonna add from n equals 1. It doesn't matter that it's n. Don't worry that it's n. 1 to 7. Thank you. Okay. All right. So go ahead. Let's just plug a couple in. Plug in 1. Plug in 2. Plug in 3. All right. Plug in 1. What do we get? You get 2 times 4 to the what power?
0.
0. 1 minus 1 is 0. Okay, what's 4 to the 0 power? 1. 2 times 1 is 2. Next, plug in 2. 2 times 4 to what power? First. That's 2 times 4, which is 8. Plug in the third one. That's 2 times 4 to what power? Second. That's 2 times 16, which is 32. What are we multiplying by? 4. All right. Do you want to keep plugging stuff in, or do you want to use the formula? Yes.
After you get that point, you know you multiply by 4. Can't you just multiply all of them by 4 to get to the what, 7?
You can, but I'd rather you use the formula because that's going to make it even more quicker. Okay? Even more quicker. Huh? Okay, so how many things are we adding? 7. So what's the first term? 2. Parentheses. 1 minus, what are we multiplying by? 4. And what power should I be using? The n power, well, what? 7, yeah. 7's n over 1 minus what? No. 4. It's 1 minus r, okay? All right, so plug the top in your calculator. What do we get? That's 1 minus 4 caret 7.
Negative
Negative 1.
16,383.
Negative 16,383. Divided by what? Negative 3. So divide it, then multiply it. What's the final answer? Well, we got this division right here, right? And then what's next out here to multiply? Shouldn't be negative. Positive what? Positive what? Huh? Shibby shibby? Huh? 922? Yep. That's it. See how? Yeah, look. Still forking. Cutlery. Questions?
Can it be negative?
It could be negative, yeah.
Well, think about it. What are you multiplying by?
All right, we got to do this last one real quick. All right, summation k. K equals 1 to 5, 1/3, k minus 1. Okay? All right, so it's okay if you use your calculator, but you're still going to plug in. What's the first thing I plug in? 1. So 1/3, 1 minus 1, 0. What's 1/3 to the 0 power? 1. Anything to the 0 power is 1. Now plug in 2. What am I going to get up here? 1. So 1/3 to the first power. 1/3. Or y'all want to use decimals? That's fine. You can use decimals. 0.33 repeating. All right? So, next, 1/3 to second power. What is that? All right, stop. It's going to be much easier. Nope. It would never equal 0. Let's actually, since you said that, Orion, let's keep going. 1/3 to the third power. What is it? What's 1/3 to the third power? So 0.37?
Yeah.
What's 1/3 to the fourth power? Have I got my 5 terms? Now, you can add them up or you could do the formula. Watch. S of 5, what's the first term? 1. 1 minus. What are we multiplying by every time? What are we multiplying by every time? Yeah. Where's my highlighter?
3.
You're dividing by 3. Well, look at this. What's that right there? 1/3. You're multiplying by 1/3, y'all. You're multiplying by 1/3. Because isn't multiplying by 1/3 the same as dividing by 3? Yep. So guess what? You're going to do parentheses 1/3 caret what power? 5, 5, 5. All over 1 minus 1/3. This can be easily done in your calculator a lot quicker than that stuff up there. All right. So if you do this in your calculator, you end up with 1 times, I don't know what the top will be, 0.995? 0.995 divided by I believe this will be this will be 0.666. So what's 0.995 divided by 0.666? You don't like that number? Sorry. It happens. What's 0.995 divided by 0.666? Well, it shouldn't be negative. Or is this negative? Is the 0.995?
That just shows that math is equal. 1.49.
Add all those up. I bet you get 1.493. Huh? Yeah. That's a 3. Because we rounded when we added it up. Did you add all these up? You did this formula? Oh. Well, I don't know. It's 2 thousandths off. I don't care. All right. Any questions? All right. I want you getting started on your homework.
What all is freshman, Mr. Branson?
Yeah. Your homework, I want you to do all of them. Yeah. Yes, all of them.
What about the ones we were going to do?
Oh, the quiz questions? Y'all want that tonight or for Friday night homework?
Friday night.
Okay. You can do it over the weekend.
Thank you.
Too much. Hey, we're not done. You're going to be working on your. You got 10 minutes almost to work on your homework. No lollygagging. In fact, I need it quiet. Killian, I think you need to put the gun magazine up. We're in math class.
Great anniversary.
Look, when you add that, you add these two, yeah. So 1.33 plus this is 1.444 plus this is 1.47. Yeah. And then you constantly add it, you get that. Exactly. Yeah, that's what I was trying to get across.
I did go to you.
Learn exactly how to write the formula. Not A sub 1, A sub n. Oh, yeah, it's this. Period. N minus 1. No, I'm going to give you your quiz for your quiz on Friday. Yeah, quick. Yeah, because a lot of folks didn't do good on their quiz. Actually, yours is pretty good. I think you made an A. It's in the grade book.
So I don't have to retake it.
No, you don't.
So I don't have any homework on the weekend?
No. Yeah.
Is the N6 how many they want?
No, it's
Like
the.
it's gonna be like the N? Oh, okay.
Burns,
Yes.
I got some.
What?
I
Yeah.
got 1, 2, somewhere. doesn't matter where you file these, so it moves it. You know what they're paint? Sided version. I heard that in Dart.
Transparency.
Yes.
Reverse problems, are we just supposed to fill in the formula?
Let's go over a couple of them on the board. All right, for the first couple problems, let's talk about it. All right, so y'all are making this harder than it is. I don't know why. Find the formula. Yeah, you just plug them in. So a sub n stays the same. I plug in for that. 3. I plug in for that. I'm done. That's it. Let's just find the formula. Guys, y'all trying to do rocket science when all we're doing is basic stuff, okay? All right. Let's do one from each section real quick. Let's jump over here. Let's find a sub 10. You want to find the common ratio and the term. Common ratio and the term named. So the common ratio is be what you multiply by. What do you multiply times a negative 1 to get a positive 3? Negative 3. All right. What do you multiply times a positive 3 to get a negative 9? Negative 3. What do you multiply here? Negative 3. So the common ratio R would equal negative 3. Now you want to find a sub 10. I would use a formula. I would find my formula. A sub n equals, what's the first term, y'all? Negative 1 times, what's the common ratio? You better put this ratio in parentheses. I don't care if you use parentheses here. I DC don't care, okay, about the parentheses here, but I do care here. So n minus 1. Now what do I plug in for n? A sub 10 is equal to, I can't write 10 anymore. Negative 1 times, you better put this in parentheses, to what power? 9. That is a 10. Sorry. I can't write 10s anymore today. And put that in your calculator and out plops your answer. Why is it 9?
Yeah.
I'm plugging in 10 for n. 10 minus 1. Okay? What's that? Positive what? All right, let's do another one from another section. We've got a couple minutes. Yeah, that's the answer. All right. What'd you get? Something different? Calculator. Negative 1 times negative 3 caret 9. Put it in your calculator. Sure. 3 times negative 6 times n minus 1. You're done. Yeah. All right, next page. Let's do one from this side. Evaluate the geometric series. Add. Yep. So, but you need 6 terms. So negative 3 plus 6 plus negative 12 plus 24. What's the next one? What are we multiplying by every time? We're multiplying by 6. Negative 3 times 6 is 6. Negative 2. Negative 2, negative 2. What's the next one going to be? Negative what? What's this one going to be? Negative 48. Somebody's following along. And then what's this one going to be? What's this one going to be?
96.
Positive 96.
Add them all up.
Add I just add them all up. That's it. Or you could use the formula. Formula's easy. Okay? Let's do number 12. Okay? That's it. All right, 12. Plug in 1. All right. Guys, this needs to be done by tomorrow. I will be checking this tomorrow. When in doubt, do what you're going to say.
You never said it's the same thing. They still get 53. It's the same
Nah, I don't want to. You want to? Hold on, let me show you. Where's my key?
Let me get this one right. Wait, I'm waiting.
No, I'm way off. Look, I haven't ate all day. I had to get here early, and so I skipped breakfast. So I goofed. So, this and this would make 60, but I wouldn't add, and then the 3 would just come down, and 3 plus 60 is 63. The answer is 63. Okay? So you're getting the correct answers.
Number 13 is right?
I'm sure it is. If you put it in the calculator right, it's right. Yeah, you did really good on your quiz. I think you made a 99 or 100.
No.
On your graphing quiz, yeah. We'll get it back tomorrow. I didn't have time to pass it back today. Alex, did you pass out some stuff for me? I have two sets of copies. And actually, I have even more to pass out.
Look at that.
Man, that was tricky yesterday. The whole cook. My fault. RT, man. Alright, so that's one and two correct things you need to pass out. Get to know you.
I need to come in to redo the quiz.
Yeah. So you haven't finished it. That's the problem.
No, not that one, but the other one.
Yeah. I mean, yeah, I'm here every day. I skip breakfast to get here 15 minutes early.
Nah, don't do that. I won't be here tomorrow.
Which one is it? Did you grade my test?
Oh, were you done?
Yeah.
I didn't know that you were done.
Yeah, I left it here. I'm done.
Okay, I'll grade you. Alright, guys. So, you're getting penned out. Who's going to pass these out? Hey, I need people to be passing stuff out. I need somebody to help me pass these out.
Hey, I got you, bro. You so good. All right. Hey, me.
I didn't even see that. Oh yeah, I did see it. I was gonna be like, hey, he lied. He said I did not tell you to throw me the ball if I could throw it.
Everybody has one, including the absent folks, in the box. Yeah. Wait. Hey, I gave money to Mr. Johnson. You do that. Huh? That's fine. Okay, guys. So your quizzes. Your quizzes or the homework you did. Get that turned in. Quizzes or the homework you did. Get that turned in over here. All right.
Which one of the questions?
Seventh period. Everybody's going to re-quiz if they feel like they didn't get a grade on their previous quiz. And the grade you got on the graph.
Wait, I got Justin.
All right.
I got this one.
Justin, I think I'm missing that one.
Guys, there's a warm-up. Starting on it.
Yeah, look.
Thank you. Is there anybody absent? Monica and India. Hey. Copy of this, whatever passed out. All right, you should be starting on the warm-up on your desk. The warm-up is on your notes. It's on your desk. Find the intersection of those two functions. What are the steps for finding intersections? Set them equal to each other. Get them all on one side. Then, yeah. Okay, so everybody should be right here. I know some people are doing jobs and stuff, but everybody else should be x cubed minus 2x. You know you're supposed to set it equal to each other. So you're going to set this equal to the other function, negative x. And you need to be working from there. Thank you, Justin. Start on the warm-up. You should be doing this. It should be on your paper, Jerry. On your paper.
Coach Branson, could you subtract the negative x?
You,
Add the negative x?
yes, you want to add that.
You can't combine. You can't combine those, right?
Yes, because they're just x's. So remember we talked about positive and negative numbers. What's this going to be?
1x. Negative 1x.
Negative 1x. And gravity.
I did it wrong way, though.
Uh-oh. What did you do?
I put add 2x.
Oh. Okay. You didn't go get it over there? Okay. All right. What do you notice about these two terms? Not difference of two squares. Not difference of two cubes. Yes, that's a cube, but there's also the one thing that you're supposed to look for every time. Every time. You're supposed to look for this every time. GCF. So take out an x. Who can tell me what's left over? Is x squared. What else? Yes. Remember, when you take out a GCF, you divide. You divide. Cancel. What am I left with? Negative 1. Very good. Okay. Now, I can factor that. What can I factor that with?
X.
Plus 1
Yes.
and x minus 1.
Yes. Okay. What's my answer going to be with this x right here? X equals 0. What's my answer going to be right here? X equals negative 1. And my answer right here? X equals positive 1. Who can explain to me? Who can explain to me why? Who can explain to me why my answer, one of my answers is positive 1? What makes positive 1 an answer?
Because you add plus one.
Yeah.
Yeah, I said equals.
Yeah.
Then you add plus one.
Yeah.
Bring it down.
Yeah.
X equals.
Yeah. What am I trying to get this all equal to?
0, but isn't it because negative 1 times 0? No. Plus.
What happened to my thing? Did it pause?
No. What you recording?
I don't know what's happening.
You are recording, Coach.
Yeah, you are recording.
I am?
Yeah.
Oh, that's not good. That's